For me, the sequence is division first. It's always division first. And then I teach addition, subtraction, multiplication, always through division.
Good morning. Welcome to Tier 1 Interventions with Jonily, Zupancic, and Cheri, Dotterer. So without further ado, I'm going to pass it over to Jonily and let us get started.
Hey, Jonily, Zupancic here, JZ in the house today. So when we're getting these kids ready for learning and being able to do that in an inclusive, least restrictive environment, Tier 1, there are certain instructional strategies that we need to focus on. If you're a general classroom teacher, administrator, support specialist, occupational therapist, speech therapist, intervention specialist, instructional coach, whatever your role is in your school or district, I want you to think and evaluate in your mind the strength of your Tier 1. Now, how do we do this? There are certain components in Tier 1, meaning how visual is the content? How much do we adapt to student visualization? How do we embed conceptual, cognitive, stimulating, multisensory approaches to our content? How is our content leveled and adaptive? What connections and associations are we making and supporting students to make? Tier 1 interventions, core instruction, we're really unpacking all of the ways that we can improve students' ability to function in the regular classroom to avoid so much pull out to small group. We want kids' needs to be met in the regular classroom. In the mathematical classroom, our ultimate goal is to improve number sense. Having students gain a really strong, innate, intuitive, natural understanding of number. Number meaning how large or small numbers are, the size of numbers, the value of numbers. The number one way to do that is through counting and rote counting without meaning. And I'll explain what I mean by that. One of our strategies is called the numeracy cycle. The numeracy cycle is a four-step process, a four-step linear process, but also a cycle that is the key to improving numeracy and number sense for all students. The components of the numeracy cycle in order, sequential, are number one, count, just rote count without meaning. The meaning comes with component number two, which is quantify. Quantify means, do I know the value? So kids can oftentimes skip count by 10, 20, 30, 40, 50, 60. But if I say, what's the quantity of 60? Tell me about 60. What's the value of 60? There's no connection between that rote counting by tens and understanding that 60 is 6 counts or 6 tens. But that's okay, because if we go back to that, rote counting is the first step. I've got to get kids good at rote counting, even if they don't have an understanding of what they're counting. Because rote counting alone, repetitively, with more and more interactions, will build an understanding of quantity and value of the number. The third component in the numeracy cycle is compare. Once I'm rote counting by a number, 10, 20, 30, 40, 50, 60, and I start to understand that 60 is 6 tens or 60 ones or 60% of 100, I can go really complex with this as I start to quantify numbers. There are so many different connections and associations and meanings. Compare means, okay, it's not about the number 60 now. Let's compare the number 60 to the number 90. Which is bigger, which is smaller, how much bigger, how much smaller. Comparison is a higher level of numeracy than just understanding the quantity or value, and it's definitely a higher level than rote counting. Finally, the fourth component of the numeracy cycle is operate. Add, subtract, multiply, divide, exponents, square root, anything that I do to compute numbers. Oftentimes what happens in the regular classroom is There's a priority and emphasis on the operations. I want kids to be able to add, subtract, multiply, and divide. Whole numbers, integers, negative numbers, fractions, decimals. And so oftentimes the focus on intervention in small group pullout is on operating numbers. However, the intervention cycle, the operate is the final component. If I have students that are struggling with operation of numbers, computation of numbers, add, subtract, multiply, and divide, let's suppose I'm having kids add 3/4 and 4/5, just as the example right now, that's an operation. I'm operating, I'm adding two fractions with unlike denominators. If students can't do that, whether I am pulling them for intervention or I'm in the regular classroom, I go back to the third component, which is compare. Can I even compare 3/4 or 4/5? I take away the operation and I look at 3/4 and 4/5, and I say to students, now remember, I'm going back to my good instructional techniques. Tell me about 4/5 and tell me about 3/4. What do you notice about 4/5 and 3/4? For a struggling math student, the number one thing that they will tell me is those numbers are equal. They are not, but I'm not going to fix it right away. We have 4/5 and 3/4. We're comparing them. They believe the numbers are equal, which means I need to go back in the numeracy cycle to number 2 component, which is quantify. I need to separate the numbers. I need to look at 3/4 by itself, use instructional strategies and approaches to help students understand the visual, the quantity, and the value of 3/4. I need to do that separately with 4/5 so they can start to have a connection, association, a visualization as to how large or small each of these numbers are separately. And that's what comparing means. I cannot intervene. I cannot do intervention on operation repetitively, procedurally, over and over. I could say to students, find the common denominator, change the numerator, blah, blah, blah. If they don't have a numerical ability to compare those numbers, and if they believe those numbers are equal, no matter what procedure I teach, they are not going to remember it and they're not going to retain it. The intervention, the tier 1, tier 2, or tier 3 intervention is to go backwards in the numeracy cycle. I'm at quantify and value. I'm looking at 3/4 by itself and 4/5 by itself. And I'm not giving you a lot of indication of the intervention that helps them understand that value because I'm teaching the numeracy cycle right now. In these sessions, we have tools and techniques that will help us do that. But if students still struggle with understanding the quantity and value, or a lot of times I say the magnitude is how large or small numbers are. For example, how far away is 3/4 from one whole? How far away is 4/5 from one whole? Which one is closer to a whole? Which one is further from a whole? How much? So that's the exercises in quantify. And if students still struggle with quantity, I go all the way back to the first foundational step of the numeracy cycle. That was the point I made at the very beginning of this. And that is rote counting. How often do we have kids rote count other than whole number? So oftentimes in the earlier grades, we will rote count, skip count by 10, skip count by 5s, 5, 10, 15, 20, da, da, da. So essential. What happens is as kids get older and as we move into new number systems like fractions, decimals, and negative numbers, we skip the rote counting. And so kids are missing that foundational step. So if you have kids that struggle with understanding numeracy and they struggle with numbers and operation and comparing numbers and numbers on a number line, the number one key intervention is to go back to rote counting of that type of number. So I might ask students, let's skip count by 3/4. 3/4, 6/4, 9/4. Rote counting is absolutely essential for starting to understand quantity of numbers. Now, if they struggle with that, let's just skip count by 1/4, 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4, 9/4, 10/4. That's it. That's it. It's as simple as rote counting without meaning. I know kids don't understand that, but then I can start to ask questions. How many counts by 1/4 will it take to get to 100? And you see how I've just twisted that perspective. And that question alone, even my most struggling student is going to say, oh my gosh, it's going to take a lot of counts by 1/4 to get to 100. How many counts by 10 to get to 100? 10, 20, 30. Oh, it's going to take 10 counts by 10. How many counts by 1 to get to 100? 100. How many counts by 1/4 to get to 100? How many counts by 1/5 to get to 100? How many counts by 1/8 to get to 100? See, rote counting is the foundation of moving into those higher level questions. And without rote counting and without asking those questions to students and without starting at the beginning of the numeracy cycle, we are never going to get kids to the operation level. So our math interventions are failing because we're not going all the way back to the rote counting of the different number systems. Janet, you just said in the chat, I noticed that some of my 7th graders had trouble counting their hearts this week because you talked about using candy hearts to look at data distribution. It was so simple, 1-to-1. Yeah, kids struggle with just counting individual. And these are what, 12-year-olds, 13-year-olds? Absolutely. When I'm working with my high school students, I have high school students that struggle or have never been exposed to rote counting by fraction. We've got to take our math lessons back to rote counting. And if you take away nothing else from this segment of the teaching, it is rote counting by every type of number, including fraction.
I know in my 6th grade classroom, we wrote count. I disguise it a little bit so that like when we just got done with dividing fractions with my one block and they had trouble. So I'm like, okay, well, let's go back to the counting. And I didn't say that to them, but I'm like, okay, what do we know about? And they just started rote counting because sometimes it's hard to they recognize rote counting as, oh, this isn't something I should be doing at 6th grade, at least my 6th graders this year. So I have to sneak it in, but that's how I sneak it in.
So you make a beautiful point, because one of the things that I'll bring up with students is, what is 6 divided by 2? And I'll do this with my high school students, as same as my 4th graders. And as a matter of fact, my 4th graders do much better with what I'm going to teach to you right now because their number sense hasn't been schooled out of them. By the time kids get to high school, they're all mixed up with all the math notation, and I have to retrain them before I can move forward with them. You can see here, 6 divided by 2 equals what? Now, no brainer. Okay. They're like, it's 3. Okay. But that's not the point. The point is not about solving. It's about skip counting. Every single division problem is skip counting. Every single division problem is skip counting. That's it. Bottom line. When we're teaching division, it's skip counting. That is why 120 chart is so essential, because this number 2, this second number here, is my skip counting number. That's what division means. I'm skip counting by 2. And what am I trying to land on? Not 100 like the 120 chart. I'm trying to land on 6. I'm skip counting by 2 to land on 6. And the question is, how many skip counts by 2 does it take to land on 6? 2, 4, 6. I can use the 120 chart to do that, or a lot of kids can just do that. Or I might need to get a manipulative out with blocks. If I need kids to be more concrete, manipulative based, it depends on their math ability level. 2, 4, 6, 3 skip counts. Here is where it gets powerful in the upper grades. If we're teaching division, if one of the ways we're teaching division is by skip counting, and what a lot of my teachers say is, they're like, Jonily, that's ridiculous. That is not a strategy that we even should be utilizing. Because if I have 231 divided by 7, teachers are like, that is not efficient. Why would I skip count by 7s all the way to 231? Because if I want to improve number sense, it's not about answer getting. It's about the process. See, and this is where we fall short in tier 1 mathematics, or even in tier 2, tier 3 intervention with mathematics. We believe that intervention is more about answer getting than it is about the process. The process is what improves number sense. And in the end, when number sense increases, then computation will increase as well. But if I want to improve number sense, I want to think about this as 7, 14, 21. Then what I want to do is start to chunk skip count. Gosh, I could get to 70 right away. How many skip counts by 7 does it take to land on 70? 10. I could count by 70s to get to 231. See, this is the power in rote counting. Now, why is this strategy important? It's important when we get to the example that Krista mentioned. When I have the problem 6 divided by a half, I know that 1/2 is my skip counting number. And if kids have had lots of interactions skip counting by halves, that's not going to be a problem by the time we get to this computation. 1/2 is my skip counting number. 1/2, 2/2. Oh, 2/2 is 1. 3/2, 4/2. I skip count by halves to land on 6. So the question here is, how many skip counts by halves does it take to land on 6? And I can do this with fraction by fraction. I can do this with any division operation of fractions. So in elementary school, what happens is we poo, sorry for the dirty language here, we poo using this skip counting technique because we're like, it's not efficient. That's a terrible way to do it. But it is the most transferable to fraction division later on. What we need to do is really prioritize these skip counting strategies early on and continue to refer to them, because that is what's going to help our students with higher level mathematics. And that is where we're falling short. Lots of things right now I want us to reflect on. I want us to reflect on, what did I just do and how was that responsive teaching? Because I skipped all the way to a different lesson. I want to reflect on what I actually taught and what connections you have. So let's pause for a moment and just process together with me everything that has just happened, because there's a lot of power in what has just happened in the last 10 minutes.
I think it's also happening along the path of literacy, but they're starting to realize that we have to understand the concepts, and hence the science of reading and the structured literacy push is making its way and will soon be mandated across the entire United States. But I see a lot of parallels. I know you have always said to me that there's no connection, but even looking at your numeracy cycle, there's a lot of literacy connections that can be made there. If kids are struggling with comparison, which is usually one of the first things that they try to introduce in the literacy. Okay, let's back up just a little bit to looking at counting. And it might be that they're looking at something else, but when
But
you
look at
start
this
talking
counting,
about
this is where your phonics is.
yeah, actually, counting is where phonemic awareness is.
There you go. There you go.
Phonics would be the quantify.
There you go.
So wouldn't it be alphabet automaticity?
Mm-hmm.
You're looking at the writing part. I was looking at the reading part. when I was
You
saying
know who
that.
I am.
That's both of you. That's a great point, because oftentimes in literacy, we combine this reading and writing, and those are two distinct. There's a cycle for reading and a cycle for writing. I love it. No, and this is absolutely paralleled to that. I agree.
Learning from you, Jonily, is the fact that everybody's talking about a forward progression. First you do add, first you do subtract, then you do this. What's to say that, and you said it, you're in division mode, and that you already did fractions. Why can't you revisit? The way Jonely's talking is there's always a revisiting, and there's nothing that says you can't revisit. And the way she's talking is, if you're going forward, there's no sense. What, did they forget what they did in the past? So you have to go back to go forward. So You just say, I am the first one to tell my kids, oops, I forgot something. When we just go back and we revisit things, or we just do something again. So there's nothing that says just because you want to try something else that you can't go back and revisit it.
Teresa, I want to stay on that point for just a moment. And I think all of you on here have heard me talk about this before, and that is operation is not sequential. Someone decided that addition should be done first, and then subtraction, and then multiplication, and then division. That is hogwash. There is no basis. There's no scientific, there's no research basis for that sequence. For me, the sequence is division first. It's always division first. And then I teach addition, subtraction, multiplication, always through division. Now, with my 5-year-olds and in kindergarten, I don't call it division. Guess what I call it? Sharing. When kids are 2 and 3 years old, we start to talk to them about sharing, and kids develop a conceptual foundation of equal sharing. They know it better than anyone. If you have more than me and I'm 2 years old, I know that, and I'm going to throw a fit about it. We need to, in preschool and kindergarten, embrace sharing, which sharing is division. So that is how I teach and how I sequence. I'm always in division world, but I call it sharing. And equal sharing means equal groups, and equal groups means skip counting by the number in that group. And Teresa, I'm glad you brought that up, because I teach on this all the time, that division should be the first operation, and we disguise it as sharing and teach all other operations through that. Now, Cheri, you have a lot to say about this. The number 4 makes Cheri and I really cranky. At least it makes me really cranky. And letters make Cheri and Teresa really cranky when you're looking at fonts. I was using the font that I like the best, which Cheri, I thought I was using Lexend. This is Arial. But anyway, I think there are certain fonts that are cleaner for number, that when the typed font is there, it connects best. But look at this 4. This isn't how kids write a 4. I had to search and search and search. This was the best one I could find on Google, and it's Pacifico. I went to Lexend for 9 because 9 had the best, I thought, structure for how we actually write. But again, it's not.
I just found Deco.
Deco on what? On Word?
I just found Deck Poppins. This is Architect's Daughter. This is Lexend, and this is Deco.
Deco it is. As a general classroom teacher, as I am, and I'm certified secondary, so 7-12 math. My bachelor's degree is in mathematics. These are things that never came across my path until Cheri and I began to learn from therapists, from Cheri. Oh my gosh, look at all the things that were barriers to learning in my tier 1 core classroom that I was just carrying on like it was nobody's business. And these little minor things were continuing to create these huge barriers for learning for kids just by the way the number 4 was typed. And so this is what tier 1 intervention is all about, is for us to strengthen these core classrooms by utilizing these strategies, these intervention strategies that combine the therapy world and education world and better connect them to each other. Even though I've grown immensely in my math instructional delivery over the years, because since my first year of teaching, I ended up studying early childhood development, brain research, cognitive science. I did everything I could to try to relearn how kids learn. And I was able to create really great experiential, adaptive, differentiated, multisensory mathematics in my classroom. But it wasn't until I met Cheri and Teresa and all of the other special support staff, occupational therapists who have these techniques from the medical world, that have these techniques, that once I then brought some of these adaptive techniques, non-academic techniques, into my tier 1 classroom, it just glorified and truly enhanced all of the great facilitational transformations I had already made. So when we look at both of these, when we say tier 1 interventions, that's why we're not saying tier 1 math interventions. We're saying tier 1 interventions because they are academic and non-academic interventions. And the only way you can get this is with the connection of both of these worlds.
I'm not a math person. I think I'm one of the worst people. I hate math to a passion, but I see where you can get me to help my kids advance on other things. Like I can help with the visual perception. I can help with the motorics because my kids need that and they can take that back to the classroom. So I'm sitting here, and as much as your trained people are sucking up stuff from you and they can go back from math, I'm still sucking stuff up from you. And I've told you this, you came and talked to us. I get stuff from you every time you talk to me that I can go and say, oh, I'm going to try that with my kids, because it's generic. I can go and take some of those same things, not math, even though they're math, I can work with them with my kids. So even though like you say, and people say, oh, poo, it's math. It's not. Like you're saying, it's something that can go across the board for general good teaching. And I think that's very important for people to know, that it's not necessarily, yes, it's weighed heavily in math, but it's not just math. So I think that's the push where a lot of people need to know that it's good teaching.
And end today with describing the best components that make for good teaching.
For me, what has really transformed my teaching with you is this idea of interactions over time. I think sometimes we get stressed about trying to get through all of our curriculum, and these kids are so far behind and all these gaps. But when you talk about they don't have to learn everything that first interaction, and even with the number our on 20 chart, we saw all these different interactions that happen. I think it's just that pressure that's off of the teacher. As a gen ed teacher, I feel that a lot. I have to get through this curriculum. And that's one thing that has really helped me stay, because I think sometimes when people get pressured and they feel like the kids have to get it now, then all of sort of these intervention strategies, they go away. At least they're like, I just need to do procedural, they need to know it, and they need to move on. So it's that interactions over time that has really changed.
Mathematics is not a hot stove or a busy street. I can let kids explore. They're not going to get hurt. And finally, as we wrap up, this has been Tier 1 Interventions. I want to thank all of you for being here today. If you're listening to the recording and you weren't here live, hopefully you got some takeaways as well. Thanks for your attention, everybody, and have a wonderful weekend.
Nalima says, Tier 1 Interventions was a sensitizing workshop. Systematically thought through, put into an easy to understand framework, and well presented. Thank you to you both. Thank you, Nalima. You've been listening to Tier 1 Interventions with Jonily, Zupancic, and Cheri, Dotterer. Tier 1 Interventions is released on the first and third Tuesday of the month. The podcast is recorded live on the third Saturday of each month except July. The first segment of the podcast is released to your favorite podcast app. To hear the entire workshop, go to tier1interventions.com and register for our mailing list to get all the news about the next episode. Be sure to subscribe so you don't miss the next episode's release. Do us a favor, give us a 5-star rating and write a review. Every vote matters. I'm Nicholas King, an intern for Cheri, Dotterer Educational Consulting,